Hey, it's Josh. Continue on from part one of our firewall video. Let's move on to some further concepts and understandings, especially dealing with network fundamentals to really understand how a firewall operates. Ports, protocols, and services, often abbreviated as PPS, but each one of these is very individual in its own way, but together they form a very critical concept and really the backbone of networking. A port is like a door, but on a computer. Just like your house has a door that allows people to come in and out, computers have thousands and thousands of doors. So let's make this comparison a little bit more scalable and bring in a hotel that may have hundreds of rooms. And each room having a door to allow the respective guests to come in and out. It's very similar to a computer. And for the sake of computer, we utilize different ports for different communications. And the idea is that we want to better organize and to also ensure that information goes where it needs to. And so one port may be specifically for web communication, while a second port may be for email. On the other hand, protocols are the rules or languages that a computer uses to communicate. Now, some protocols focus on how data moves between computers, but the two main important ones we're going to look at are TCP or Transmission Control Protocol. And this is mostly used for reliable mail service, and it makes sure that all the data gets delivered in the right order. On the other hand, you have UDP or User Datagram Protocol, and this is kind of like sending a quick message and you're not really worried if it arrives perfectly. Services are like the specific tasks or jobs that a computer does for you, and these are often running in the background. They rely on protocols to get the job done. Think of it this way. Protocols are the rules for communication, whereas services are the actual tasks or functions that have to follow those rule sets. Okay, so let's piece this all together with a few examples. And this is going to incorporate ports, protocols, and services. So first up, let's say our task is to send and receive emails. And so right off the bat, we know that we're going to use a service that is used for email delivery. Well, let's move up to our protocol that's, again, going to provide the rule sets of how it communicates and such. And so we're going to use Simple Mail Transfer Protocol, SMTP. And this is going to be utilized on port 25. So again, in total, we have our email delivery. That's going to be our service. Then we have our protocol, SMTP, and we're going to utilize port 25. Up next, let's say we have the task of wanting to send or receive a file. And so for our service, we want to use a file sharing service. Up to our protocols, there are two very popular options, which we have File Transfer Protocol, or FTP, or Server Message Block, also known as SMB. At a port level, FTP may use port 20 and 21, and then SMB may use port 445. For our last example, let's say maybe we want to browse the internet and be able to visit websites. And so what we're wanting to utilize is a web service. At the protocol level, we most likely will use Hypertext Transfer Protocol, also commonly known as HTTP, and this would utilize port 80. Now that we've covered our networking fundamentals, including ports, protocols, and services, we can get a better idea of how firewalls work. And essentially, they're going to utilize these combinations of ports, protocols, and services to either determine what is allowed or what's not allowed. In our part one of the firewall videos, we saw that there is ingress and egress traffic and that we could either allow or deny any kind of traffic in there. And those rule sets are going to heavily rely on PPS to determine, again, what is or is not allowed. And I'd like to further illustrate the point that firewalls don't just operate on what's bad or what's good. Rather, it's more essential to identify what is actually used, what is necessary, what kind of communication should be going through. Just because email itself isn't bad in nature and it's very often and commonly used, if our environment or if our computers or our devices don't utilize email in that sense, we shouldn't allow it. And so just erase from your mind the thought that things are inherently bad or good or allowed or not allowed. Rather, I'd like you to understand that these firewall rules should be constructed, established, and designed in a manner that is suitable for your environment. But let's move on to some examples to further demonstrate how a firewall operates and utilizes PPS. Today we're going to demonstrate the operation of a firewall using Cisco's Packet Tracer, which is a network simulator. And essentially you can build out an entire network or just use several devices to demonstrate how different things connect and how they operate, figure out how they communicate, so on and so forth. It's a really, really awesome tool. And the best part is that it's completely free. All you need to do is go to Cisco Networking Academy, create an account, log in, and then from there you can download Packet Tracer, install it on your computer, log in, and you can do exactly what I'm going to show you today. And just for a quick reference, this is the website here, right? You log in with your account and then you can go down and download the installer here. And especially depending on your computer, they have a different flavor for you, whether you use Mac, Ubuntu, or Linux distribution, or Windows. Let's begin with a little bit orientation of the environment we have here. Pretty simple in nature, but we have a computer, just like a desktop you would be utilizing, a web server, which would be hosting a website of some sort, and then our firewall. Here you'll see that it's an ISR or an integrated services router. So this is, in fact, yes, it is a router, but it also does possess some firewall-like capabilities. And so today we're going to utilize that as our firewall for simplicity's sake. Now that we're orientated, let's get back to our lesson where we're trying to show how ports, protocols, and services can control traffic or communication between devices. And so in our example, what we're going to have is this computer here trying to access a website on this web server. And as you could see through the communication channels here, is that there is this firewall sitting in between. And this firewall will be able to host those rule sets that either allow or prevent that communication from occurring. This demonstration is going to be focused on using web services, specifically HTTP and HTTPS, which we covered a little bit earlier in our video. And more specifically, we're going to be trying to access the website on this web server. And if we look at this web server, hover over here for just a second, we'll see that the IP address is 10.1.1.2. So we're going to go into our computer over here, and they have the typical programs you would see on a desktop. We're going to access the web browser, which it's going to look pretty accurate to a very plain and basic web browser, but we're going to try to access that website. And first we're going to start with HTTPS. So we're going to type that out here, followed by that IP address. And we hit enter, we see that it actually does reach a website. And again, since this is a network simulator, there's not any high-tech graphics or anything like that. It's not very sophisticated in that manner. This is just for demonstration purposes. And we can see that there is a web page here though, and we can, kind of click through these things. But again, there's not going to be anything very sophisticated. Let's go ahead and close the browser. Let's open it back up and let's do the same thing, but type in HTTP. And you'll see same result. Regardless if we use HTTP or HTTPS, they can both access the web server. Now, our goal in this lab is to limit that traffic specifically to HTTPS when accessing that web server. The goal behind that is these two protocols offer something a little different from one another. While they're both considered web services, HTTPS, that little S on the end, stands for secure. And essentially, it's going to be securing that traffic or that connection. And what I want to demonstrate further is in our networking academy, we can see that URL actually uses HTTPS. And so essentially, Cisco is enforcing that secure connection. Now, what we can do is try to remove that S and try to utilize the HTTP. And when we hit enter, we'll see that we're navigated back to the website. But if we look at that URL again, we'll see that it actually redirected to HTTPS. So they're enforcing HTTPS, and when you try to use HTTP, they're actually going to redirect you to HTTPS. And if you don't have great familiarity already with HTTPS and HTTP, I fully plan on releasing additional training that expands on secure communication and what is the real difference between HTTPS and HTTP. But for the sake of this video, just know that our goal is to prevent HTTP and only allow HTTPS to access that web server. Now, returning to the PPS side and how we can incorporate that into rule sets within the firewall, remember we have ports, protocols, and security. So let's kind of figure out how we can mix these together within a firewall and create that rule. So when we go into our firewall here, which again, you can see that it says router here. This is a router, but it's going to be performing functions that would be accessible at a firewall level. And so what we're going to do is create those rule sets utilizing our port protocol. What we're going to go ahead and is put those two rule sets in here. And let's break that down. Rule number one is we're saying to deny the TCP protocol from any specific source to any specific destination that is utilizing www. Now, www is the World Wide Web service, and this service is used exclusively for port 80 or HTTP. And so what we're saying in this first rule is to deny any TCP traffic from anyone to anyone that is trying to utilize HTTP or port 80. Then the second rule says to permit any IP address from anywhere to anywhere. Essentially saying any IP address can talk to any IP address. And that rule sounds a little crazy, but what's happening is these two rules are stacked, meaning that it's going to go in order whenever traffic comes in or communication, right, that is attempting to traverse across. It's going to look at these two rules and determine if the traffic or communication that is flowing through matches either rule set. And so if this computer tries to communicate over HTTP, the firewall is going to look at this rule first and determine if that traffic matches. If it does, it's going to perform the action, which would be to deny that traffic. If it does not match this, it's going to move on to the next rule, which in this case will say permit. So essentially, if HTTP traffic comes in, it's going to match that first rule set, and that is going to be the action taken, meaning it's going to deny. But if we use HTTPS traffic and that comes across, it's going to not match that first one, and it's going to see that second rule, which means that anything else can go through. And so let's see that in action. First, let's make sure that HTTPS is able to go through. So we'll once again type in that URL. Awesome. So we're able to hit that website. We're able to go through, and we can see that there's nothing stopping us there. Let's go ahead and close that browser, open a new browser, and let's retry that again, but use HTTP. You see, I'm not sure if you heard that keystroke, but I hit enter, and we see that nothing instantly came up. And what it's trying to do is resolve this specific URL, but you can see that we got a request timeout. Now, we can further investigate this utilizing a simulation, which is really, really awesome within Packet Tracer here. Let's go ahead and set this up for that specific function. We're going to go ahead and move this out of the way so we can kind of get a better idea or a better visual here. Open that browser again, and we're going to kind of stage it for exactly what we just tried, but we're not going to hit enter yet. And what we're going to do is hit simulation. And what this is going to do is take us in a step-by-step flow of that traffic or that communication. Let's go ahead and hit go. And this is what's going to trigger it. Again, it's going to be on a step-by-step process, or it's going to be delayed. So meaning after every action we take, we're going to kind of see that flow. So let's hit go. And you'll see that that packet appeared here. And what we can do is take the simulation panel here and watch as it goes. And you can see how that envelope turned red once it hit the firewall and it returned there. And what we can do is go through these individual time frames, and we can go through the different layers here. A lot of what you're seeing on screen is definitely a little bit higher level. Again, more stuff we're going to cover later in these videos as they're released, but I just want to give you the idea of how we can see that this is actually rejected here. Okay, so let's look at this specific screen right here. And we're going to kind of go through these layers to better determine where this exactly stopped. Let's look here at layer 3. The receiving port has an inbound traffic access list with an ID of 101. The device checks the packet against the access list. And we'll see here the packet matches the criteria of the following statement. And here we have our deny statement. Deny TCP any equals www. The packet is denied and dropped. And again, this rule is saying we're going to deny any TCP that is from any host or any source bound for any destination, and it is equaling www or HTTP port 80. And we can see that's why it is being dropped. And if you want to see that simulation again, let's go to the very beginning, right? Where we initiated that traffic from the browser, and we see that packet originates at the computer, goes to the firewall, and then from there we can see that the red packet is being sent back. showing you that it was denied. Now let's reverse this to kind of see what that process looked like beforehand. So let's go ahead and close our simulation. Open that firewall again, right, where we had those two rules. And let's go ahead and remove that. Now, let's switch back to real time so we see everything happening. And let's go ahead and run this again. And we'll see, boom, we're able to access it again over HTTP. Let's launch that web browser one more time. Let's go ahead and stage it, switch over to our simulation, and let's go ahead and launch it. Again, we see that that packet is created once we generated that traffic that is bound for the web server. We see it go and hit the firewall this time, and we see it's actually able to proceed further, hit the web server. We see the web server traffic is returned to the firewall, and that's where it gets back to the computer. So we can see that that firewall rule is no longer in place, and that traffic is actually able to traverse the network. And while this is a very simple example, and there is so much more sophisticated ways of implementing this, and obviously this is also a very, very small network, something that is kind of unrealistic that you would see out there in the wild, especially in a professional or production environment. But this is kind of where all the basics and fundamentals start. And I'd definitely be happy to go over more of this kind of technically focused training, especially on the networking side. I'm going to release a whole video discussing networking and why I think it's probably one of the greatest skills that you need to learn, but we'll save that for next time, and definitely provide any suggestions or any comments you have on this, especially anything that you really want to learn or focus on, or just any questions in general. While I aim to provide much more content and further explanation in terms of firewalls and networking fundamentals as a whole, I hope that this video brought a little more clarity regarding ports, protocols, and services. And thank you so much as always for being here.